Root Systems and Soil Health, A Farmer's Guide. Introduction. This guide presents research data showing how different plants create underground organic matter that maintains soil structure, water retention, and microbial health. Understanding these processes can help reduce dependency on tillage, irrigation, and chemical inputs. Key research findings on root systems, annual crops. Crop. Root depth. Root shoot ratio. Root biomass, dry tons/acre. Soil volume influenced. Key benefits. Corn. 6 to 8 feet. 0.4 to 1. 1 to 2 tons. 25 to 30% of soil volume. Creates vertical channels, supports mycorrhizal networks. Wheat. 3 to 6 feet. 0.5 to 1. 0.8 to 1.5 tons. 15 to 20% of soil volume. Fine, fibrous roots that improve soil aggregation. Cotton. 3 to 5 feet. 0.3 to 1. 0.5 to 1 ton. 10 to 15% of soil volume. Taproot system that breaks compaction. Rice. 1 to 3 feet. 0.6 to 1. 0.7 to 1.2 tons. 15 to 20% of soil volume. Dense mat of roots in upper soil profile. Potatoes. 1.5 to 3 feet. 0.2 to 1. 0.3 to 0.7 tons. 5 to 10% of soil volume. Shallow but dense root system. Key research findings on root systems, tree crops. Tree type. Root depth. Root spread. Root biomass, dry tons/acre. Soil volume influenced. Key benefits. Citrus. 2 to 5 feet. 2x canopy width. 5 to 15 tons. 30 to 40% of soil volume. Extensive fibrous root mat. Mango. 18 to 20 feet. 2-3x canopy width. 10 to 25 tons. 40 to 50% of soil volume. Deep taproot with extensive laterals. Peach. 3 to 6 feet. 2x canopy width. 8 to 12 tons. 30 to 35% of soil volume. Spreads widely in upper soil profile. Grapes. 6 to 15 feet. 3-4x canopy width. 5 to 15 tons. 25 to 35% of soil volume. Deep penetrating roots that access deep water. Visual understanding of root architecture. Different plants have distinctive root architectures that impact soil structure. Fibrous root systems, grasses, wheat, rice. Create a dense mat of fine roots. Excellent for topsoil structure. Prevent erosion. Increase water infiltration in upper soil layers. Taproot systems, cotton, many trees. Penetrate deep into soil. Break through compacted layers. Access deeper water sources. Create vertical channels for drainage. Combination systems, corn, many vegetables. Both deep and spreading roots. Influence larger soil volumes. Support diverse microbial communities. Root exudates, the invisible contribution. Roots release 20 to 40% of the carbon captured by plants as exudates into the soil. These carbon-rich compounds feed beneficial soil microbes. Help form soil aggregates. Create sticky substances that bind soil particles. Improve water retention capacity. Build long-term soil carbon. What happens when we till? Tillage effect. Impact on soil structure, time to recover. Root removal. 75 to 90% reduction in soil binding agents. 1 to 3 years. Organic matter loss. 5 to 20% per tillage event. 3 to 7 years to rebuild. Microbial disruption. 40 to 60% population reduction. 6 to 12 months. Compaction increase. 30 to 45% reduction in pore space. 2 to 5 years with active root growth. Water infiltration. 60 to 80% reduction. 1 to 3 years with cover crops. The living bridge, how roots connect soil particles. When roots grow between soil particles, they create pathways for air and water, release binding agents that hold particles together, support fungal hyphae that extend the root network, decompose slowly, leaving channels for future roots, feed microbes that create stable soil aggregates. Healthy soil with root networks versus collapsed soil after tillage. Cover crop root contributions. Cover crop. Root depth. Special benefit to soil structure. Cereal rye. 4 to 5 feet. Creates over 300 miles of roots per plant. Daikon radish. 1 to 6 feet. Biodrills through compacted layers. Clover. 2 to 3 feet. Fixes nitrogen while building soil structure. Sunflower. 3 to 5 feet. Large taproot creates lasting channels. Practical applications for farmers. Minimize bare soil time. Every day of bare soil accelerates collapse of soil structure. Aim for living roots year-round when possible. Reduce tillage intensity. Each tillage event destroys approximately 30% of remaining root structure. Consider no-till or conservation tillage approaches. Diversify root systems. Include crops with different root architectures in rotation. Mix shallow and deep-rooted plants. Use cover crop cocktails. Multiple species create complementary root networks. Different decomposition rates provide both immediate and long-term benefits. Transition gradually. Begin with small test plots to build confidence. Observe improvements in water infiltration and soil structure. Document reduced need for irrigation and inputs over time.